Professor, Electronics and Telecommunication Engineering, Walchand Institute of Technology, Solapur. In continuation with the earlier video, we are going to discuss the machine learning techniques. At the end of this session, students will be able to describe what is machine learning. Contents. In this video, we will discuss the difference between what is predictive task and descriptive tasks. Then we are going to discuss what is training and testing. Then we are going to discuss finally the performance metrics of machine learning algorithms. So, the predictive and descriptive tasks which are there and how the machine learning techniques can handle it, that we are going to discuss. So, the promise of doing right and becoming a data-driven organization is great. Data analytics provide solutions to extract meaning from the huge volumes of data to help improve decision making. So, huge amount of data nowadays it is available, but extracting required information is very important, and that is done by using this predictive and descriptive analysis. So, data analytics can be categorized into three distinct types. One is descriptive. What is meant by descriptive? Which use data aggregation and data mining to provide insight into the past and the answers the questions like what has happened. So, from the data, what has happened in some organization we can look at by using this descriptive analysis. And next is predictive analytics, where we use statistical models for forecasting to understand the future, and we can answer the questions like what could happen in the organization. So, that is called predictive analysis and descriptive. So, both these tasks can be done by using machine learning techniques, that is descriptive as well as predictive. And the third one is prescriptive analytics, which use optimization and simulation algorithms to advise on possible outcomes and can answer the questions like what should we do. So, it is different from the prediction that a course of action can also be described by this predictive analytics. Here, the machine learning models are first trained and then they are tested. So, what is training and what is testing, that we are going to discuss. So, training data and test data are two important concepts in machine learning, where the training data is the observations in the training set form the experience that the algorithm uses to learn. So, from the data, the machine forms the experience from the data, and that algorithm learns the data. And for test, the test set is a set of observations used to evaluate the performance metric of a machine learning model. So, using test data, we can evaluate the performance of the machine learning model and using some performance metrics. Which are those performance metrics, that also we are going to discuss. If the test set does contain examples from the training set, okay, the algorithm will simply memorize it and will fail to predict the value of the response variable for new examples. That means if the test data is present or we take from training data itself, then the machine learning algorithm will fail for the new data. So, the task of algorithm just will memorize it. On the other hand, if the test data is different from the training data, then it will generalize well and will be able to effectively perform a task with a new data. So these two are very important, that is testing data is from the training set only, or testing data is outside of the training set. If it is outside the training set, then it generalizes well, means it can predict the new data also. But if the testing data is from training set only, it is sometimes may fail to predict the new outcome. Memorizing the training set is called overfitting, and generalization of the training set is called underfitting. So what we required is the balance between these two. Overfitting also we don't require, and underfitting also we don't require. Okay, because to underfitting means it is generalized, and overfitting means it is just memorizing the training data. So balancing memorization and generalization is called regularization. So regularization in machine learning is also very important, which balances between overfitting and underfitting. And these are the metrics to some of the metrics to evaluate the performance of a machine learning algorithm. And the third set is called validation set, and is used to tune variables which control how the algorithm is learned. So validation is a new set of data which is used to tune the variables in the algorithm so that it can learn the data. Question: what percentage of data distribution between training and testing and validation is used in practice? Pause the video and answer the question. So to answer this question, the distribution between training, testing and validation is roughly we can say 50% or more than 50% is used for training, 25% is used for testing, and 25% is used for validation. Then we will see some of the performance metrics of the algorithms. There are two fundamental causes of prediction error for a model, that is called bias and variance. So what are the sources of error which occur in prediction of a output, that is bias and variance? What is bias? A model with a high bias will produce similar errors for an independent input. Okay. So if the inputs are different, the model will generate similar errors, okay, when the system is more biased. Okay, but when different inputs are there, and if it is generating different errors, then we can say the model is with high variance. So a model with high variance conversely will produce different errors depending upon the different inputs. So again here we require a balance between bias and variance. We don't want both extremes. So if you look at the accuracy, another measure of the evaluation performance of a machine learning algorithm. So accuracy measures the instances that were classified correctly. Precision measures the ratio of correctly predicted positive observations to the total predicted positive observations. So these are just definitions of accuracy, precision and recall. And finally, the recall is the ratio of correctly predicted positive observations to the all observations in actual. So here just precision is described here. So precision consists of true positive plus true false positive is equal to total predicted positive. So if you look at the predicted value, these are negative, positive, and here actual. So actual is negative, positive, and predicted are true negative, false negative, and in positive column false positive, true positive. So precision is true positive divided by true positive plus false positive. So that comes out to be true positive plus false positive can be called total predicted positive values. So precision is true positive divided by total predicted positive. And recall is true positive plus false negative, that is actual positive. So if you look at the table, right side there is a predicted values, and to the left side there are actual are negative, positive, and if I see the second row, positive consist of false negative and true positive, and recall is a true positive divided by true positive plus false negative. So true positive plus false negative can be called as total actual positive outcomes. Okay. So with this I used references like as before, that is Tom Mitchell by Machine Learning by Tom Mitchell, and Foundations of Machine Learning by Mehrer Mohri, MIT Press Conference. So thank you very much.